Alright, in this video we are going to be talking about the fundamental theorem of calculus. It essentially states that if f is continuous on the closed interval a to b, and capital F is the antiderivative of f on the the closed interval a to b, then the integral from a to b of f of x is going to be f of a, f of b minus f of a. And here's going to be our notation for that. So essentially this is going to be finding the area under the curve from 1 to 2 of x squared minus 3. So we're just going to take the antiderivative like we've been doing. So 1/3 x to the third minus 3x, and then from 1 to 2. I'm going to plug in 2, and then I'm going to plug in 1. So we're going to plug in our upper limit. And it's also important to note, very important, to be using brackets and parentheses, because this right here is a minus sign right here. We don't want to get confused with subtraction here. Then we have 1/3, 1 to the third, 3, 1. And honestly, at this point, just call it a day. All right? You don't need to simplify your answers. Maybe on the MCQ you will. But for right now, keep it pretty, aka like this. Don't simplify it. All right, same thing with number 10 here. We want to find the area under the curve from 1 to 4 of 3 times the square root of x. I'm going to move the 3 over up front so that I only have the square root of x. Now we know that from previous videos that the integral of x to the 1/2 is just 2/3 x to the 3/2 from 1 to 4. I still have the 3 as my coefficient, but now I'm just going to evaluate 4 as my upper limit and then 1 as my lower limit. So now I have 2/3, 4 to the 3/2 minus 2/3, and then 1 to the 3/2, which is just, 2/3. But just keep it like that. All right. For number 11 here, we want to find the area under the curve of sine from 0 to pi. And this right here, remember that the integral of sine is negative cosine. So I just want to find that. So I'm just going to plug in pi, and I'm going to plug in 0. So negative cosine of pi minus negative cosine of 0. And honestly, just leave it like that and call it a day. Of course, you'll be expected to, simplify and whatnot. Now looking at number 12 here, number 12 is a little bit different because we have x plus 2 and x minus 3. We don't really have any other methods besides expanding this out as of right now. So we're just going to have to expand this so that it is from, 0 to 1. So x squared minus x minus 6 dx. Integrate this. And then go from 0 to 1. And then one thing about this is that notice how my lower limit is 0, and if I were to plug in 0, everything is 0. So honestly, the only thing I need is going to be my upper limit of 1. Now, would this work 100% of the time? No. Because, for example, if I were to do something like the integral from 0 to 2 of e to the x, the integral of e to the x is e to the x. And that's going to be e to the second minus e to the 0. And we know that e to the 0 is 1. So sometimes be careful whenever you are trying to plug in 0. Don't ignore it. Now, the reason why we were able to ignore it here was because this was a polynomial. Same thing here. Cosine of 0 is 1. So don't ignore this because cosine of 0 is 1. All right. For number 13, I'm going to do this 2 ways. I'm going to do the algebraic way, and then I'm also going to do the geometric way, aka using geometry. I'm going to use geometry first because I think that's going to be the easiest, and then you'll see why that's the easiest method. All right, so I'm going to go ahead and move the 2 up front. So I have 2 times the integral from 0 to 2 of x minus 1, the absolute value of x minus 1. Now this right here is just an absolute value where I'm shifting 1 to the right. And I want to find the area from 0 to 2. So we have this area right here. So from 0 to 2, we got to think about how I'm shifting the absolute value. My vertex is at 1 right here. So my length here is just 1. And then to find my height, I need to figure out what this is evaluated at 0. Now, if I evaluate this at 0, that's just going to be 1. Same thing with this right here on the right side. My distance from 1 to 2 is just going to be 1. And then my height, if I were to evaluate 2, is 1. So then we get 1/2 plus 1/2, which is 1. However, you don't want to forget about this 2 right here. So that's going to be 2 times 1, or 2. So for number 13, your area here is going to be 2. And that's how we use geometry. Just like how we use geometry on the other lesson. Now, we are at the point where we can technically use the fundamental theorem of algebra. It's just that we got to split this up. Notice how here we have the integral from 0 to 2 here. And we kind of have 2 parts. We have this part at 0 to 1, and then we have this part right here from 0 to 2. And notice how this part right here from 0 to 1 is technically negative x plus 1, and then this right here is x minus 1, if I were to extend this over. So using my properties of absolute value, remember that we could write the absolute value of x minus 1 to be negative x plus 1, and then x minus 1. Meaning that I can technically do an integral from 0 to 1 of negative x plus 1 dx, plus the integral from 1 to 2 of x minus 1 dx. Now, you're going to see pretty quickly why it's better to use geometry, if we can, to find the area, because right now, I'm going to have to use the fundamental theorem of calculus twice. The first part's for this one right here, this integral, and then for this integral right here. And of course, we still have this 2. Don't forget about this 2 right here. Okay, so if I were to integrate this part right here, I'm going to have negative 1/2 x squared plus x from 0 to 1. Now, once again, if you were to plug in 0, that's just going to be 0. So I have negative 1/2, 1 squared, which is just negative 1/2. Okay, and then I have the integral from 1 to 2. So this part's right here. That is going to be 1/2 x squared minus x from 1 to 2. I'm going to plug in 2 as my upper limit. And then I'm going to plug in 1 as my lower limit, my lower bound. And at this point, I do want to simplify because I want to prove that my answer is 2. So here, 4 minus 2 minus 1/2 minus 1. So I have 2 minus 2 minus 1/2 minus 1, 0 minus negative 1/2, which is just 1/2. Okay. So then I have plus 1/2 here. Which means I did something wrong. Let's see. I know. Oh, I forgot the 1 right here. I know. I really am.
Silly you.
I know. Silly me. So, I forgot the 1 from this whenever I evaluated 1. So that's going to give me 2 times 1, or 2. And see how all of that mess whenever you could have just done geometry. I know. Okay, let's see. Number 14, you're going to use geometry or use FTC, whatever works for you. 15, we're going to do the same thing here, where we want to evaluate this lovely integral for k is greater than 0. Now notice how your function here is going to be continuous for k is greater than 0. And because since k is greater than 0, whenever I integrate 1 over x, I'm going to drop my absolute value bars just because, once again, k is going to be greater than 0. So then I have ln of k squared minus ln of k. I'm going to extend this further by using my properties of logs. This is now going to become 2 ln of k minus ln of k, which is just ln of k. Okay. Now for number 16 here, we want to evaluate the limit by interpreting the sum as a Riemann sum for a function defined on 0 to 1. So you know already that your bounds are going to be from 0 to 1. You just need to figure out what your integrand is. So based off of this, notice how I have a radical, all the way to the n. So this is going to tell me that I probably have the square root of x right here. Now using FTC, once again, we know that the square root of x becomes 2/3 x to the 3/2 from 0 to 1. And your answer here is just going to be 2/3, because if you were to plug in 0, that's just going to be 0. All right, 17. This one's going to be the last one. And then, yeah. 17 here, we want to find the integral from 2 to 6 of f of x plus 2 dx. Now, remember that this plus 2 does not mean that we're going to add 2 at the end. Remember that using our properties of integration, that we're finding the area of 2 with a length of 4, because from 2 to 6, that's the length of 4, and I have a height of 2. Let me put dx right here, dx. So we already know that the integral from 2 to 6 of x dx is 7 from what they gave us. And then we know that from FTC, technically, we have 2x, and then that's just going to be 2, 6 minus 2. So that's why we are able to do that, just finding that rectangle. This is going to be 7 plus 2 times 4, or 15. All right. In class, we are going to be talking about the mean value theorem for integrals, and this has a fancy word for it, aka average value. So we'll do that in class, along with other practice problems related to FTC and whatnot.